Okay, so I promised I would do this problem, which I didn't have enough time for in lecture. It's a pretty simple vector addition problem. I know the magnitude and orientation of FA here. So I know this vector. And you want to know the magnitude and orientation of FB. So this is the thing I'm looking for, so that the resultant force is directed along the positive y-axis and has a magnitude of Fr equal to 1500 newtons. So it's a vector addition problem. I need to add Fa and Fb together in order to get Fr. And the question is, what is Fb? So let's write what we're trying to do in vectors. We want Fa plus Fb equals to Fr. Now the problem's asking for Fb, so I'm going to try to isolate the thing I'm looking for. Let me rewrite this equation as Fb equals Fr minus Fa. Okay, so if I knew the Cartesian components of Fr and Fa, I can subtract those to get the components of Fb. So that's what we're going to do now. We're just going to express these two as in Cartesian components. So let's take first Fr. In Cartesian components, I'm going to write it like this. The magnitude Fr times j hat. It has a positive y component. It has no x component. And let me just remind myself that the magnitude Fr here is 1500 newtons. So I know that magnitude. I'm just not going to put in numbers until the very end. Similar thing to do is that Fa, I'm going to write it like this. Magnitude Fa times the sine of phi I hat plus magnitude Fb, Fa, cosine of phi j hat. So both of those come with positive signs, plus and plus, because the vector Fa has a positive y component and a positive x component. And the x component goes with the sine of phi because it's opposite to the angle phi, and the y component goes with the cosine of phi. Okay, so now we just need to write down the components of Fb. So Fb, to get the x component of Fb, I have to take the x component of Fr, which is 0, minus the x component of Fa, which is the magnitude Fa sine of phi I hat. Right? And then to get the y component, I have to take the y component of Fr, which is the magnitude of Fr, minus the y component of Fa, which is the magnitude of Fa, times the cosine of phi j hat. So we have now, this is Fbx, that's the x component of Fb, and this is Fby. You can see that the x component of Fb is negative because, remember, the magnitude of Fa is positive. Whoops. And it will turn out that the y component of Fb will be positive, which agrees with the picture, the way that the picture looks. Okay, so in fact, I know all these numbers. I can get a number for Fbx and a number for Fby, and then figure out the magnitude and direction in the regular way. So I'll do that on the next slide. So let's just stop here, and then we'll go to the next slide to put in the numbers. Okay, so all I did is rewrite what I wrote on the previous slide. This here is Fbx, including the minus sign, and this is Fby. So for example, if I want the magnitude of Fb, I just do the usual thing that I do for all vectors, square root of Fbx plus Fby squared. So if I put in the numbers here, I'm going to get the square root of magnitude Fa sine of phi squared plus magnitude FR minus magnitude FA cosine phi squared. I know all those numbers, so that turns out to be magnitude FA is 700 newtons times the sine of 30 degrees squared plus 1500 newtons minus 700 newtons cosine of 30 degrees squared. And out of this, you put it in your calculator, I got 959.9 newtons. Okay, now that's the magnitude. For the direction, I will not go through it, I'll just write the formula. So I'm looking for this angle theta here. So let me use the formula that I'd given in class. Inverse tangent, theta is the inverse tangent of FBY over FBX. So notice I put the absolute values. I'm going to put in positive numbers inside of this inverse tangent. And out of it I got, when I put in all the numbers that I knew for FBY and FBX, I got 68.6 degrees. And then remember, you have to look at a picture to tell yourself where is this measured from. So if I look at my picture, that's 68.6 degrees above the minus x axis. So that is our answer for the direction and the magnitude. Hope you enjoyed.